Hi guys, welcome to Algorithms Made Easy. My name is Khushbu and in this video we are going to see the fourth part of the question, best time to buy and sell stocks. You are given an integer array prices where price of I is the price of a given stock on ith day and an integer k. Find the maximum profit you can achieve such that you may complete at most k transactions. Note here is given that you may not engage in multiple transactions simultaneously. That is, you must sell the stock before you buy again. Here are some examples given to us and the explanation with this example. So let's take one of the examples and see visually how we get the output for this question. So here I have the prices array and the value of k. This means that from all these days we need to find the maximum profit that I can achieve by doing only one transaction as k is 1. So in that case, I am going to consider this particular transaction that will give me a profit of 6. Now let's see what happens when k equal to 2. In that case, I can consider one more transaction which is this one, and the profit now becomes 6 plus 4 which is 10. What happens when I increase k to 3? In that case, I can break down this entire transaction into two different transactions which will maximize my profit to 11. So you can see that the number of transactions affects the profit that you can achieve over here. In the previous videos, in the previous versions of this question, we have seen that k given to us was fixed. Over here in this question, the thing changing is k. So now, how do we solve this question? With the varying k condition, we have different transactions that we need to consider for attaining the maximum profit. And so we need to store these transactions that are giving us the profit somewhere, which makes us think that can we use dynamic programming in that? Because the idea behind dynamic programming is storing the intermittent result and using that result to find the output. So the answer is yes, and we are going to use dynamic programming for this question. So let's go ahead. Here is a DP array wherein the row represents the number of transactions that we can perform and the columns represent the days at which this transaction is happening. So we have a DP array of rows representing k and the columns representing days. Now, initially, we can say that on the 0th day, which is this column, we can attain a profit of only 0 rupees because the maximum that we can do is buy on this day and immediately sell on the same day, which gives us profit as 0. Secondly, if we see this 0th row, which means that if you are only given that you can perform 0 transactions, you cannot make any profit, and so the profit remains 0 in this particular row also. So this is the pre-filled condition for this DP array that we are going to consider. Now, what does this cell represent? It represents that given I can make at most 2 transactions, what is the profit I can achieve till 5th day, starting from day 0. That means this is DP of 2, 5. And here what we can say that either I can make a transaction on this day or not. Now what does not making a transaction mean? It means that I am considering the profit from the previous day because that could be the maximum profit I can achieve today. Or else you can do a transaction which is completing a transaction or selling the stock on the current day, which means that you bought the share or stock on some previous day which is given over here by X. So what this means is that you bought this stock on day X, which can range from 0 to j minus 1, which is this column minus 1. Now this was your ith transaction. So what about the previous I minus 1 transactions that you did? The profit for that is already calculated in the I minus 1 row. So that value will be the value in this particular row for the day on which you are buying the stock for ith transaction. So let's see this with an example. If you sell it on this day, which means you bought it on some previous day. Let's consider you sold on day 5 and you bought on day 4, which means this is your ith transaction. Now the profit from I minus 1 transaction is nothing but this particular cell value, which is profit from I minus 1 transactions that completed on day 4, on the day you bought the stock for your ith transaction. Make sense? Let's move ahead. For this cell, if we do not consider any transaction, it means that we are considering the previous cell value, which is 0 over here in no transactions, and for this we'll consider from x equal to 0 to this column minus 1, which is 0 to 0, and we'll find the maximum profit. So that will be by saying that let's try to buy on all the previous days, which means from x equal to 0 to 0, because we do not have any previous days further than this, we say that it will be buying on this, selling on this, which makes the profit 2 minus 3, which is minus 1, plus I'll consider the profit of I minus 1 transactions, which is 0 transactions profit from the day I bought, which is on day 0. So this is the value that I'm going to consider. So maximum of 0 and minus 1 is obviously 0. So that's the answer for this cell. So now let's move ahead. Over here, I can either make no transaction, which means that my profit is going to be equivalent to the profit that I made on the previous day. That is represented by DP11. Or else I can sell the stock on this current day, making me buy the stock on any of the previous days, which is either day 0 or day 1. So for x equal to 0 to 1, I am going to find out the profit. For 0, the profit becomes 6 minus 3, which is the ith transaction, plus I minus 1 transactions profit from day 0, which makes it 0. So 6 minus 3 plus 0 is 3. Similarly, if I am buying the stock on day 1, it makes my profit as 6 minus 2 for this transaction, and for the previous transaction my profit will be from the row 0 and column same as the day I bought the stock, which is column 1, and the profit from that transaction was 0. So my profit here becomes 6 minus 2 plus 0, which is 4. Maximum of all of this is 4, and so we write it down in the DP array. Now moving forward, for this cell also we are going to do the same thing, that is, if no transactions, I'll take previous profit, which is 4, or else I'll complete a transaction today, which means I buy on either day 0, 1 or 2, which is this x equal to 0, 1 and 2. If I buy on 0, that means my buy price becomes 3 and my sell price is 5, and the profit for this k equal to 0 is always going to be 0. So substituting that 0 over here, we get the profit as 4, because max of 4 and this max of all these is 4. So let's put that over there and move ahead. Similarly, when you move ahead, you get the profit as 4 for this particular day also. I'll suggest you to do a dry run of all the columns for this row over here and tally it with the result that I am showing you on screen. So this is the calculation over here. Moving ahead, again the profit is 4 on day 5 as well. When you move ahead, the profit still remains 4, and when you move to the last position, the profit changes, because now the transaction that you are going to consider is 0 to 6, which would give you the highest profit. So over here, if you see, the previous transaction had a profit of 4, and if you calculate the cell of this day and buy from all of these days, the maximum profit you will get is over here on day 4, which is 6 minus 0 plus 0. So this gives you the answer if the transactions told to us were only 1, the maximum profit you could have achieved is 6. Now let's go to the second row, that is k equal to 2. over here you can have maximum of 2 transactions over the period of days that is given to us. So for this particular position, it would simply be 0 because it's either the maximum of previous day's profit or the profit by completing a transaction today, which means I bought on the previous day or one of the previous days, which here is day 0 in this condition. So my profit for that particular transaction will be -1, which will give me maximum of 0 minus 1 is 0. Moving ahead, over here I can either not perform any transaction, that is take the previous profit, or perform a transaction, that is sell on the current day and buy on any of the previous days. So for x equal to 0, that is buying on the previous day, my result becomes 6 minus 3 plus the profit from doing I minus 1 transaction, which is doing one transaction till day 0, which is 0 itself. So that gives me 3, and similarly for x equal to 1, which means 6 minus 2 from the ith transaction and this 0 from the previous I minus 1 transactions. That gives me 4, and the maximum of all these values is 4, so we put 4 in the arrow. For this day 3, we'll consider previous 3 days of transactions. So you can either sell at 5 and buy at 3, sell at 5 and buy at 2, sell at 5 and buy at 6. So that gives you these values, and for all those values you are going to consider a value of I minus 1 transaction, which is a transaction value from this particular row for the day you are going to buy. So for x equal to 0, you are going to consider this 0. For 1, you are going to consider this 0. For 2, you are going to consider this 4. And all this thing gives you a maximum profit of 4. Moving ahead, same thing, perform the dry run by yourself and match it with the one present on your screen and see if you get the same solution. Moving ahead, over here the profit changes. So let's see how it changed. I am either going to consider the profit from previous day or sell on the current day. Selling on current day means buying on any of the previous days. So what I am going to do is I am going to see whether I can buy on this and make the maximum profit, buy on day 1 and make the maximum profit, and so on, which gives me the values as this. Now the change over here is for x equal to 4, that is on 4th day, because I am buying on 4th day and selling on 5th day, which gives me a profit of 3 minus 0, that is 3, and the profit that I made till that point for I minus 1 transaction was 4. So 4 plus the profit from current transaction, which was 3, is 7. And the maximum of all of this becomes 7. So this gets updated. Similarly, going ahead, you get 7 for 6th day, and for the 7th day, you get a profit of 10, because you are going to consider the profit from this transaction and the profit from this transaction. So these are the 2 transactions that are considered in this case. I'll suggest you guys to dry run this by yourself and match it with the one that I have shown on screen, and you will get a better understanding of the solution as how it is working. Now let's go to 3. This one is simple. We get 0. When we move ahead, over here we get 4 by considering whether I can transact or no transaction. So if no transaction, this is going to be the previous answer, or completing a transaction will mean that I am selling on this, which means I bought on any of the previous days. Over here, this is going to give me a profit of 4, which is being considered in this sell value. Moving ahead, if I consider the previous day's profit, it gives me 4 as the answer, or else I can sell on the current day, which means I bought on any of the previous days. If I buy on day 0, it gives me a profit of 5 minus 3, which is 2, plus this 0 from making I minus 1 transactions till day 0, which is 2. Again, if we consider this, we get a profit of 5 minus 2, which is 3, plus the profit from I minus 1 transactions, which is 0, which gives me 3 for x equal to 1. If we take x equal to 2, we get a profit of 5 minus 6, which is minus 1, plus the 4 units of profit from the previous 2 transactions, which gives me 3. So what I am going to consider is maximum of this 4 or all these values, which is going to be 4 itself. Moving ahead and doing the same, we get the profit as 4. Now over here the profit becomes 7. Moving ahead, the profit remains 7 as we have considered 2 transactions, which is this one and this one. So now let's move ahead and see the dry run for the last position or the last cell. So over here I can either consider the profit from previous day by doing no transaction, or I can do a sell transaction on this particular day, which means buy on either day 0, 1, 2, 3 or till 6. So let's see all these. If I try to buy on day 0, which means I'll get a profit of 6 minus 3 from the current transaction and a profit of 0 from the previous 2 transactions, which gives me a total profit of 3. If I do the same on day 1, it gives me current profit of 6 minus 2, which is 4, and the previous profit for this was 0, which makes my profit as 4. For day 2, it gives me a profit of 0 from current transaction because 6 minus 6 is 0, and from the previous transaction I made a profit of 4, so that gives a total profit of 4. On day 3, if I buy, I get the profit of 6 minus 5 from the current transaction, and from the previous 2 transactions my profit was 4, so that gives me a total profit of 5. Moving ahead, for day 4 I am buying at 0, selling at 6, that gives me a profit of 6, and the previous profit was 4, so total profit becomes 10. For day 5, I am buying at 3, selling at 6, giving me a profit of 3 from the current transaction, and my previous profit was 7, that gives me a total of 10. Now let's come to the last one, which is day 6. If I buy at 2, sell at 6, current profit is 4 and the profit from previous 2 transactions is 7. So 4 plus 7 gives 11, and that's what we are going to fill over here because that is the maximum that we can achieve. So at the end, the last corner cell is your answer, that is the right bottom cell. So this is how you can apply the formula and solve this particular question. So now let's go ahead and code it out, and then we'll see how we can optimize this solution. So let's take a few variables handy. So we'll take a DP array which will be of k plus 1 and n. Now let's write a base condition, that is where n is less than 2, which means we have this array of prices of length maximum 1. That means our profit is going to be 0 because we only have either 0 or 1 day. After that, we'll take a loop and fill the DP array. Over here, my DP of ij is going to be the maximum value of either the no transaction option or sell on the current day. The no transaction value would be the previous value, which is DP of I and j minus 1. And the current transaction value is going to be something. For that, we will be writing another method. So let's take a helper wherein I will be passing the current I value, j value, the prices array and the DP array. After I have this, finally my result is going to be in the right bottom cell, which is dp of k and n minus 1. All that's left with us is writing the helper method. That is going to return an integer and it has the value of the current k, the value of current x that we considered in our examples, the prices array which is an integer array, and the dp array which is also a integer 2D array. Over here we were looping from 0 to x. So let's write that loop, and we were trying to find the maximum profit we could have achieved. That means we need a max variable. Initially let that be 0, and this would be maximum of something. Now what this something is? This is sell on the current day, which is day x, buy on the day for which the loop is running, and add the previous I minus 1 day's profit to it. This is nothing but dp of k minus 1 transactions till the current day for which you are looping. So that gives us either max or this particular equation that we need to write, which is prices of x minus prices of I for buying on day I and selling on day x. And the profit from previous one would be dp of k minus 1 and I, that is k minus 1 transaction completing on ith day. Finally return max, and let's run this, and it's giving a perfect result. Let's submit, and this got submitted. Now what is the time complexity for this? Over here for this for loop, if you see, the time complexity is k into n, and if you see for this helper method, the time complexity is going O of n. So the entire time complexity is this k into n multiplied by n. So that becomes k into n square, and the space complexity is maximum this dp array, which gives us O of k into n. So this is space. Now how can you reduce this time complexity over here? To reduce this time complexity, we have to find some way wherein we can get rid of this helper method. So now what this helper method is doing is, it is giving us the profit from the current transaction, that is profit from completing or selling it at current point. So let's write it down here, and we know the profit formula. Profit is equal to sell price minus buy price. Now over here sell price is nothing but price of j. Now what about buy price? This buy price can also be the effective buy price that we saw in the part 3 of the same question. So if you haven't watched that video, the link is in the top and also in the description. I'll recommend you guys to go and first watch that video if you don't understand the effective buy price calculations over here, because that I have explained much more deeply in that previous video. Now, in the previous video, we saw that effective buy price was price that I paid from my own pocket for the current transaction, which means I considered the profit from all the previous transactions first, and then whatever difference money was required to buy at current price, that was the money that was the effective buy price for this current transaction. So now over here the profit becomes SP minus effective buy price, and this effective buy price is the price of the current stock minus previous profit. That previous profit is dp of k minus 1 and j. So my effective buy price over here becomes price of j minus the profit. So we can use all these things in place of this helper that we have written over here. So now let's take this helper out and write this equation over here. So that becomes sell price, price of j minus the effective buy price. wherein effective buy price initially was price of 0, and now let's update this effective buy price. Over here, this effective buy price will be the minimum of either the previous buy price, that is this, and this formula, which is price of j minus dp of I minus 1 and j. And with this, all this code is not required. So let's run this code again, and forgot to initialize it as int. Let's run it. It gives a perfect result. Let's submit this, and it got submitted. Now, what is the time complexity for this? The time complexity for this one is O of k into n, because we have removed helper method, and the space complexity is O of k into n as it was earlier. So that's it for this question, guys. I hope you liked the video. Don't forget to click the like button, and do not forget to subscribe to our channel if you like watching our videos. Please do share your thoughts in the comments, and I'll see you in the next one. So till then, keep learning, keep coding.